Welcome back. So in the last video, we covered some of the fundamental computer vision libraries in PyTorch. The main one being Torch Vision, and then modules that stem off Torch Vision. And then of course, we've got torch-utils.data.dataset, which is the base dataset class for PyTorch, and data loader, which creates a Python iterable over a dataset. So let's begin where most machine learning projects do, and that is getting a dataset. Getting a dataset. I'm going to turn this into Markdown. And the dataset that we're going to be used to demonstrating some computer vision techniques is Fashion MNIST, which is a take of the dataset we'll be using is Fashion MNIST, which is a take on the original MNIST dataset, MNIST database, which is Modified National Institute of Standards and Technology database, which is kind of like the hello world in machine learning and computer vision. Which is, these are sample images from the MNIST test dataset, which are grayscale images of handwritten digits. So this, I believe, was originally used for trying to find out if you could use computer vision at a postal service to, I guess, recognize postcodes and whatnot. I may be wrong about that, but that's what I know. Yeah, 1998. So all the way back at 1998. How cool is that? So this was basically where convolutional neural networks were founded. I'll let you read up on the history of that. But neural networks started to get so good that this data set was quite easy for them to do really well. And that's when Fashion MNIST came out. So this is a little bit harder. If we go into here, this is by Zalando Research, Fashion MNIST. And it's of grayscale images of pieces of clothing. So like we saw before, the input and output, what we're going to be trying to do is turning these images of clothing into numbers and then training a computer vision model to recognize what the different styles of clothing are. And here's a dimensionality plot of all the different items of clothing, visualizing where similar items are grouped together. There's the shoes and whatnot. Is this interactive? Oh no, it's a video. Excuse me. There we go. To serious machine learning researchers. We are talking about replacing MNIST. MNIST is too easy. MNIST is overused. MNIST cannot represent modern CV tasks. So even now, Fashion MNIST, I would say, has also been pretty much solved, but it's a good way to get started. Now, where could we find such a data set? We could download it from GitHub, but if we come back to the Torch Vision documentation, have a look at datasets, we have a whole bunch of built-in datasets. And remember, this is your extracurricular to read through these for 10 minutes or so each. But we have an example. We could download ImageNet if we want. We also have some base classes here for custom datasets. We'll see that later on. But if we scroll through, we have image classification datasets, Caltech 101. I don't even know what all of these are. There's a lot here. CFAR 100. So that's an example of 100 different items. So that would be a 100 class, multi-class classification problem. CFAR 10 is 10 classes. We have eMNIST. We have Fashion MNIST. Oh, that's the one we're after. But this is basically what you would do to download a data set from torchvision.datasets. You would download the data in some way, shape, or form, and then you would turn it into a data loader. So ImageNet is one of the most popular, or is probably the gold standard data set for computer vision evaluation. It's quite a big data set. It's got millions of images, but that's the beauty of Torch Vision, is that it allows us to download example data sets that we can practice on, or even perform research on from a built-in module. So let's now have a look at the Fashion MNIST data set. How might we get this? So we've got some example code here, or this is the documentation, torchvision.datasets.fashionmnist. We have to pass in a route, so where do we want to download the data set? We also have to pass in whether we want the training version of the dataset or whether we want the testing version of the dataset. Do we want to download it? Yes or no? Should we transform the data in any way, shape, or form? So we're going to be downloading images through this function call or this class call. Do we want to transform those images in some way? What do we have to do to images before we can use them with a model? We have to turn them into a tensor, so we might look into that in a moment. And target transform is, do we want to transform the labels in any way, shape, or form? So often the datasets that you download from torchvision.datasets are pre-formatted in a way that they can be quite easily used with PyTorch, but that won't always be the case with your own custom datasets. However, what we're about to cover is just important to get an idea of what the computer vision workflow is. And then later on, you can start to customize how you get your data in the right format to be used with the model. Then we have some different parameters here and whatnot. Let's just, rather than look at the documentation, if in doubt, code it out. So we'll be using fashion MNIST, and we'll start by, I'm going to just put this here, from torchvision.datasets, and we'll put the link there. And we'll start by getting the training data. Set up training data. I'm just going to make some code cells here so that I can code in the middle of the screen. Set up training data. Training data equals datasets.fashionMNIST. Because recall, we've already, from TorchVision, we don't need to import this again. I'm just doing it for demonstration purposes, but from TorchVision, import datasets, so we can just call datasets.fashionMNIST. And then we're going to type in root. See how the doc string comes up and tells us what's going on. I personally find this a bit hard to read in Google Colab, so if I'm looking up the documentation, I like to just go into here. But let's code it out. So root is going to be data. So where to download data to. We'll see what this does in a minute. Then we're going to go train. We want the training version of the dataset. So as I said, a lot of the datasets that you find in torchvision.datasets have been formatted into training dataset and testing dataset already. So this boolean tells us, do we want the training dataset? So if that was false, we would get the testing dataset of fashionMNIST. Do we want to download it? Do we want to download? Yes, no. So yes, we do. We're going to set that to true. Now, what sort of transform do we want to do? So because we're going to be downloading images, and what do we have to do to our images to use them with a machine learning model? We have to convert them into tensors. So I'm going to pass the transform to tensor, but we could also just go torchvision.transforms.toTensor. That would be the exact same thing as what we just did before. And then the target transform, do we want to transform the labels? No, we don't. We're going to see how they come, or the targets, sorry. PyTorch, this is another way, another naming convention, often uses target for the target that you're trying to predict. So using data to predict a target, which is I often use data to predict a label. They're the same thing. So how do we want to transform the data? And how do we want to transform the labels / targets? And then we're going to do the same for the test data. So we're going to go datasets. You might know what to do here. It's going to be the exact same code as above, except we're going to change one line. We want to store it in data. We want to download the training dataset as false because we want the testing version. Do we want to download it? Yes, we do. Do we want to transform it, the data? Yes, we do. We want to use toTensor to convert our image data to tensors. And do we want to do a target transform? Well, no, we don't. We want to keep the label / the targets as they are. Let's see what happens when we run this. Downloading fashionMNIST, beautiful. So this is going to download all of the labels. What do we have? Train images, train labels, lovely. Test images, test labels, beautiful. So that's how quickly we can get a data set by using TorchVision datasets. Now, if we have a look over here, we have a data folder because we set the root to be data. And then if we look what's inside here, we have fashionMNIST, exactly what we wanted. Then we have the raw, and then we have a whole bunch of files here, which TorchVision has converted into datasets for us. So let's get out of that. And this process would be much the same if we used almost any dataset in here. Of course, they might be slightly different depending on what the documentation says and depending on what the dataset is, but that is how easy TorchVision.datasets makes it to practice on example computer vision datasets. So let's go back. Let's check out some parameters or some attributes of our data. How many samples do we have? So we'll check the lengths. So we have 60,000 training examples and 10,000 testing examples. So what we're going to be doing is we're going to be building a computer vision model to find patterns in the training data and then use those patterns to predict on the test data. And so let's see a first training example. See the first training example. So we can just index on the train data. Let's get the 0th index, and then we're going to have a look at the image and the label. Oh my goodness, whole bunch of numbers. Now you see what the 2 tensor has done for us? So we've downloaded some images, and thanks to this Torch Vision Transforms 2 tensor, how would we find the documentation for this? Well, we could go and see what this does. Transforms 2 tensor. We could go 2 tensor. There we go. What does this do? Convert a PIL image, so that's Python image library image, or NumPy array to a tensor. This transform does not support Torch script, so converts a PIL image or NumPy array, height, width, color channels in the range 0 to 255 to a Torch float tensor of shape. See here? This is what I was talking about, how PyTorch defaults with a lot of transforms to CHW. So color channels first, height, then width, in the range of 0 to 1. So typically red, green, and blue values are between 0 and 255, but neural networks like things between 0 and 1. And in this case, it is now in the shape of color channels first, then height, then width. However, some other machine learning libraries prefer height, width, then color channels. Just keep that in mind. We're going to see this in practice later on. So we've got an image, we've got a label. Let's check out some more details about it. Remember how we discussed, oh, there's our label, by the way. So 9, we can go train data.classes, find some information about our class names. Class names. Beautiful. So number 9 would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this particular tensor seems to relate to an ankle boot. How would we find that out? Well, one second, I'm just going to show you one more thing. Class to IDX. Let's go train data.class to IDX. What does this give us? Class to IDX. This is going to give us a dictionary of different labels and their corresponding index. So if our machine learning model predicted 9 or class 9, we can convert that to ankle boot using this attribute of the train data. There are more attributes that you can have a look at if you like. You can go train data dot, and then I just push tab to find out a bunch of different things. You could go data, there's the data, that'll be the images, and then I believe you can also go targets. So targets, that's all the labels, which is one big long tensor. Now let's check the shape. Check the shape of our image. So image.shape and label.shape. What are we going to get from that? Oh, label doesn't have a shape. Why is that? Well, because it's only an integer. So, oh, beautiful. Look at that. So our image shape is we have a color channel of 1. So let me print this out in something prettier. Print image shape, which is going to be image shape. Remember how I said it's very important to be aware of the input and output shapes of your models and your data? It's all part of becoming one with the data. So that is what our image shape is. And then if we go next, this is print image label, which is label, but we'll index on class names for label. And then we'll do that. Wonderful. So our image shape is currently in the format of color channels height width. We've got a bunch of different numbers that's representing our image. It's black and white. It only has one color channel. Why do you think it only has one color channel? Well, because it's black and white. So if we jump back into the keynote, Fashion MNIST, we've already discussed this. Grayscale images have one color channel. So that means that for black, the pixel value is 0. And for white, it's some value for whatever color is going on here. So if it's a very high number, say it's 1, it's going to be pure white. If it's like 0.001, it might be a faint white pixel. But if it's exactly 0, it's going to be black. So color images have 3 color channels for red, green, and blue. Grayscale have 1 color channel. But I think we've done enough of visualizing our images as numbers. How about in the next video, we visualize our image as an image? I'll see you there.